Ever fancied a cosmic fireworks show? Meet WR-104, a Wolf-Rayet star on the brink of going supernova. Now just imagine a gargantuan giant in our galaxy, teetering on the edge of explosion, ready to send a wave of hot gas and radiation towards our humble planet. Isn't that something? We are R104, a star in its twilight years, lacks helium to fuel its core. Instead, it's forced to burn through heavier elements like oxygen. This process disrupts the delicate equilibrium between gravity and fusion within the star, causing it to shed its outer layers. Now, here's where it gets interesting. When the oxygen finally depletes, which could be tomorrow or 8,000 years from now, WR104 will explode in a supernova. But this won't be your typical cosmic fireworks show. Oh no, WR104 is one half of a binary pair, and these two stars feed into each other, accelerating their stellar winds to incredible speeds. Some scientists speculate that the explosion will align with the axis of spin, which, as fate would have it, is pointing directly at us. But don't start packing your bags just yet. We're far enough away that even a directed supernova won't harm us. However, there's a potential part of the explosion that could be deadly, a gamma-ray burst. Now, it takes a very specific and rather unlikely chain of events for a Wolf-Rayet star like WR104 to create a gamma-ray burst. And even if it does, there's a chance that WR104 might be pointed far enough away to miss us. But in the world of astrophysics, we never rule anything out. So while WR104 might be one of the weirdest stars, it's also potentially one of the most dangerous. But don't worry, astronomers will be keeping a close eye on this star, just in case. After all, it's only 7,800 light years away, so we'll keep a close eye on this distant star, won't we? Imagine a star that refuses to fade away. That's IPFT-14HLS for you, a supernova that defies the norm. This celestial wonder was discovered by Yair Arkavi and his team back in 2014. Initially, it seemed to follow the usual life cycle of a supernova, brightening then starting to fade. But then, astonishingly, IPFT-14HLS did something unexpected. It brightened once more, effectively rising from the dead. Now this is a highly unusual event because supernovae don't typically get brighter after they've begun to fade. But IPFT-14HLS wasn't done with its surprises. It went on to fade and brighten at least 5 times in total, deepening the mystery surrounding its behavior. The enigma didn't stop there. When the team measured the supernova spectrum, the rainbow of light which reveals the velocity, composition, and temperature of a star, they found that it was evolving 10 times slower than other stars, meaning that when it seemed to be 60 days old, it was actually 600 days old. Arkavi and his team were puzzled. Each of these peculiarities was hard to explain individually, let alone together. IPFT-14HLS was breaking all the theoretical models of supernova behavior. So what could be causing this odd behavior? Well, there are a few theories. One is that the supernova could be colliding with surrounding material, which then glows. Another theory proposes that IPFT-14HLS is actually a massive star-shedding material to hold off its own collapse. But neither of these theories fully explain everything. The truth is, we still don't understand how IPFT-14HLS is possible. Its existence continues to challenge our understanding of stellar life cycles. IPFT-14HLS truly breaks all theoretical models of supernova behavior. It's a stellar enigma that continues to puzzle us. This star, the star that wouldn't die, is a cosmic reminder that the universe still has many secrets left to unveil. In the constellation of Camelopardalis, 2 stars are dancing a rare cosmic waltz. Welcome to the world of my Camelopardalis. This celestial spectacle is not your usual starry pair. Instead, these stars are in a fast-paced orbit, spinning around each other at over 1,000,000 kilometers per hour. The dance is so intense, their atmospheres are starting to interact, blurring the lines between where one star ends and the other begins. Now, let's delve a little deeper into the characteristics of my Camelopardalis. These 2 stars are not lightweights by any stretch of the imagination. One tips the scale at 32 solar masses, while the other is even heftier at 38 solar masses. For perspective, 1 solar mass is equivalent to our sun's mass. So you can imagine the immense gravitational pull these 2 stars exert on each other. But what makes my Camelopardalis truly fascinating isn't just their mass or their dizzyingly fast dance. It's the fact that these 2 stars are on a collision course. That's right. These two celestial bodies are expected to merge, morphing into one enormous star. When this cosmic event occurs, the result will be a single star with over 60 solar masses. That's a supergiant in the making. This phenomenon of two stars merging is something that astronomers have long theorized but never observed. If the predictions hold true and My Camelopardalis does become a single star, it would be a first. It would validate theories about how supergiant stars, some of the largest and most luminous stars in the universe, are formed. It could potentially rewrite our understanding of stellar evolution. My Camelopardalis is a testament to the dynamic nature of our universe. It's a cosmic dance of two becoming one that might just unlock the secrets of supergiant stars. From stellar wind machines to undying supernovae and merging stars, our universe is teeming with peculiarities. Let's recap what we've learned today. WR 104, the stellar wind machine, is a ticking time bomb in our galaxy. Its eventual supernova explosion could potentially send a gamma ray burst our way, making it not just one of the weirdest but also one of the most dangerous stars. Next we have IPTF 14HLs, the star that simply refuses to die. Its repeated brightening and fading shatters all our conventional understanding of supernovae, adding a wonderful layer of mystery to our cosmos. Lastly, we looked at My Camelopardalis, a binary star pair on a collision course. Their eventual merger will create a supergiant star, a process that has long been hypothesized but never witnessed. So, the next time you look up at the night sky, remember there's a whole universe of weirdness out there, just waiting to be discovered.